Okay, hello everybody. I'm going to talk right now about system that I'm working on. Um, it's evolutionary neural nets to try and do financial trading systems. System has just been operational for a day or two, and so this is what it looks like when it's running. Um, you see there's a bunch of windows on the screen. Down here is system messages. Uh, this is the results of a current evolutionary run. The first column here is the generation number. The second column is how many seconds have passed. The third column is the profitability during the training session, where 100% is break even. So you can see that, as expected, in the training sessions, it's doing very well. This is how it's doing in the testing period, for which there's no feedback is going back to the evolutionary system about how well it's doing in the testing period. The system trades all of these instruments. Um, it's a sort of a variety of different things. QQQ represents the Nasdaq. SPY represents the S&P 500. DIA represents the Dow. And there's a whole bunch of select. This FSRPX, I believe, is the Fidelity Select Energy ETF. And there's a whole bunch of different Fidelity select ETFs. There's also a gold mining ETF. There's short-term, intermediate, and long-term bonds, both government bonds and corporate bonds. So that is the inputs to the system. It's also the outputs that the system will trade all of these. So you can see in the current system, it's doing well with the Select Energy ETF and doing poorly with the gold mining ETF. So this is just a snapshot. Um, we're going to look at what the parameters are. There's only been 2 runs that have run so far when I took this snapshot. But let's take a look at the script that sets this thing up. So this is the script that sets things up. So you set all these parameters, and then essentially you just run the experiment. Let me go over the parameters briefly. You have the name of this particular set of runs. I call it short runs because I'm only letting it run for 25 generations. So that's an effort to avoid overfitting, is to not let it run too long. It's going to do 12 runs. The population size is 500. The number of neurons in each neural network is 500. Well, potential neurons. The way the topology of the neural net is set up, not all the neurons might be used, but that's the number that could be used. The same with the number of connections. Here it's set to 2,000, but not all 2,000 are going to get used. Then I've set the number of generations to 25. I've set the training dates and also the testing dates. So the training dates is for the year 2020, and the testing dates is for the year 21. There's other factors. There's an input noise factor. local mating range, uh, tournament 1 selection size, tournament 2 selection size, um, and your probability of mutation. Each genome has two parts. There's one part that considers what inputs the neurons are going to use, and the other part controls how the neurons are linked to each other. So each of these have a 10% probability of mutation. This is the actual script that runs the program. So after you've set all these variables, you then simply put in the command run experiment. So the results from this particular run were that here you see the training data, and it's been sorted by run. There were 12 runs, and so I sorted it from worst to best. And those are the blue bars. And of course, they do very well. They're getting, you know, um, well, 100% is break even. So if it was 100%, you'd get back whatever you'd invested. And so they're returning 500%. So essentially 5 times up to 600. But that's the training period, so it's expected to be good. It's working with perfect hindsight. And then the test results are down here, shown with the red bars, and they range from about 106% to 200%. So 106% would be a 6% return on investment, and 200 and something percent would be more than doubling the investment. So if we look at the next screen, this is the table that generated the last results, and you can see here that the median for training was 528, and the median for test was 167, which it seems really good. I'm skeptical. Like I said, I've been running the system for a couple days. Actually, it was just today that all this output was generated in the system. So I've only been looking at this output for one day. The means are here. The important values are over here. That the mean return during the testing period was 75% return. So it says 175, but again, 100 is break even. And the standard deviation here is 53. So you do have some that returned like 106, which would be a 6% return. And then there's others that went as high as 268% return. So roughly 1.5 times what was invested. This chart is over here is the same. It's just been sorted so that the graph would look nicer. Now, the median was 167.24, which just happened to be run 12. And so now here we're going to look at the details of run number 12. So this is the returns as shown in each generation. Like I said, I cut this thing off at 25. I don't know why it went to 26 there, but in any case, the this graph up here, that's the training period. that's not really so important. Uh, it's the testing results that is kind of interesting. It doesn't, some of these graphs showed that the testing results improved as the training results improved, but a lot of them were just like this. So um, it comes up with an investment strategy that works pretty well in the testing period, and it does it almost immediately. So interesting result. The the table that created this is shown here. It just shows these columns show the number of the generation. This is the number of the score. I'm sorry, this is the number of seconds that uh, have passed towards each generation. So this thing ran in 478 seconds. Let's see, 600 would be 10 minutes. So let's call this 500. So a little less than 8 minutes. The the next column shows how well the training is doing, and you can see that it goes up uh, as would be expected for training data. And then this is the results of testing with the model generated in each generation. So the and we can see it starts with the 39-45% return and ends up with a 67% return. And then at the bottom just reports that the run is finished, um, and that it used 21 gigs, and this this particular run, well, actually, this report here is the runs finished. I'm not sure. I think this went faster than 8 minutes per. No, it took. I should correct this. I should have it say run finished and not runs finished. In any case, that's pretty much a summary of where I'm at so far. It's a little early to get too excited, but it does seem like the results are pretty good. The preliminary results are looking good. Okay, thank you, and that's all I got for now.